Many billions of years ago, all the matter in the universe was concentrated into one small, very hot, very dense region. That region exploded in what we call today the Big Bang around 13.7 billion years ago, give or take a couple of billion, and then we had a time of dark ages that lasted for around 400 million years. Now 13.3 billion years ago, the first stars came into existence. About 7 billion years ago, they came together, started forming galaxies, planets, solar systems, etc. And our little solar system, very young one, came into existence about 4.5 billion years ago, if the calculations are correct. That's the age of the sun and the earth, etc. Then the evolutionary process of Earth started coming into play. First of all with the Precambrian era. Okay, that's when bacteria and algae started forming, marine invertebrates, mainly without shells, sponges, worms, etc. Okay, they came into the place, and the Earth started growing rapidly after that, going into the Paleozoic era with the Cambrian era, where marine shelled invertebrates started appearing, the first vertebrates such as fish started appearing, and we ended with the Permian era, where the reptiles started taking over the Earth and large insects were abundant. After that there was the Mesozoic era, the Triassic, Jurassic and Cretaceous periods, okay? That's when dinosaurs started to roam the earth and the first mammals to appear. The first birds appeared when dinosaurs were at their peak, and at the Cretaceous era the dinosaurs died out and flowering plants started taking over the world. Then we have the Cenozoic era, okay, where the first primates appear, apes and elephants. There were lots of grass over the earth, a rapid spread of grazing animals, flowering plants started being abundant, and then at the end of the Cenozoic era, the Quaternary, that's when humans started coming into play about 2.5 million years ago. Large mammals were abundant, and then about 10,000 years ago, the humans started dominating the earth. We know all of this because we can study it. We can see the way the sun behaves in our solar system, the way the planets revolve around the sun, the way the moons revolve around the planets. If we look at the stars, if a star is 1 billion light years away, we know that it took light 1 billion years to reach us. So from that we can calculate the ages of the planets and the age of the universe. We can do it through carbon dating by inspecting the fossils. Talking of fossils, we can extract the DNA of the dinosaurs and study that, etc. All of that puts us in a place with our modern day technology where we can really very precisely calculate the ages and the time periods and the dates of all the happenings in the history of the earth. Okay, for those who haven't figured it out yet, today I'm gonna take on the bubble busting of the age of the earth. I'm not gonna talk about the evolutionary process because that merits a bubble busting of its own. I'm just gonna talk about the age of the earth. I'm not gonna tell you how old the planet actually is, just simply because nobody knows for sure. But what I am gonna do, I'm gonna tell you how old it is not. I'm not taking sides in any religious sector, okay? I just want to specify that. I'm not taking sides with the creationists and their scientists saying that the world is 6,000 years old. I'm not taking sides with the evolutionists saying that the world is 4.5 billion years old. I'm not taking sides with any other religion or philosophy or nothing. I'm just going to attack this problem head on using science, math and logic, okay? That's it. I know a lot of people would disagree on this, and I would probably get a letter from the scientific community saying how wrong I am, etc. Okay, if I'm wrong, prove me wrong. Go for it. I will be the first to admit it when I'm wrong. Okay, I admit my mistakes, but just hear me out on this video first and then make up your own conclusions afterwards. Let's first talk about the sun. This is a scale model of the solar system, and we can see where Earth is right over here. That's very close to the sun, but that distance is still equal to 149,597,870 kilometers. That's a huge distance, okay, give or take a couple of kilometers. That is equal to 8 light minutes. It takes light from the sun about 8 minutes to reach the Earth. In 1979, scientist Eddie and Bernaysian was observing the sun, and they took the observations of other scientists before them, and over 400 years they calculated that the sun was shrinking at a rate of around 6 feet per hour. Now, I do not take sides with these guys, because some of their colleagues on the other hand did their own experiments, their own measurements, and figured out that Bernaysian and Eddy were wrong, and the sun was shrinking at around only 2.5 feet per hour. Now, even at 2.5 feet per hour, if we take the time scale back 20 million years, the sun would have been so big it would have touched the Earth. A healthy debate started occurring between scientists on the age of the solar system after that, because the shrinking sun would disprove a lot of theories of the older universe. So yeah, I read the reports of Gillian and Stephenson and the other guys, okay? All of them were great renowned scientists. Some of them said the sun is actually expanding, it's not shrinking. Some of them said that it's shrinking and expanding over a period of 80 years. But mostly they all concluded that the sun is shrinking. The amount it's shrinking by is up to debate. Some of the guys narrowed it down to 30 centimeters per hour. That's less than a foot, but even at 30 centimeters an hour, that would give you between 150 and 260 kilometers per century. Okay, so that is still a huge amount of expansion, even at that small amount of 30 centimeters per hour. Okay, that 30 centimeters per hour, it is superimposed on the rate of contraction and expansion of the sun over the 80-year cycle. 30 centimeters per hour, that would give you 100 million years before the sun would touch the Earth. Okay, so even at that very low amount, 100 million years, and the sun would be touching the Earth is still very plausible, very reliable, in order to debunk the fact that the Earth is 4.5 billion years old. Okay, so like I said, there's no conclusive evidence so far as to how much the sun is shrinking, the rate of shrinkage, okay? It is up for debate. That's for you to believe whatever you wish to believe. Most scientists, however, did conclude that the sun is losing mass, but let's go with the minority of the scientists that says that the sun is not shrinking at all, it's staying the same size, but it's only losing its mass. I'm not sure how that works, but fine, let's go with those guys. Let's assume that their assumptions are correct, and let's see how we can use that. Okay, we can actually calculate that due to the sun's diet, it's losing 1.353 times 10 to the 20th grams every year in mass. That's a huge diet. It loses a lot of mass. Losing a lot of mass means that in the past there was more mass. More mass means more gravity. More gravity means stronger attraction on the Earth. That's a huge problem for people believing the solar system to be very old. These are things that we can actually prove that should be taken into account when people are assuming the age of the solar system, okay? It's not difficult calculations, anybody can do it. I mean, I'm not a physicist or a mathematician, and I came up with it basically on my own, so just think about that before you start speculating on the age of the solar system. But enough about the sun, let's go into something else. Let's talk about the moon. Now, the moon is moving away from Earth at a couple of centimeters per year, nothing to worry about. Moving away from Earth means that at some point it had to be closer. Now, the moon causes the tides, and according to the inverse square law, if we bring in an object half the distance, we quadruple the attraction, make it 4 times stronger, the gravitational attraction between the Earth and the moon. The moon causes the tides. So a couple of million years ago, the moon would have been so close to Earth that the tides on Earth would have been so high that everything on Earth would have drowned twice a day. That's a very big problem when trying to prove the age of the Earth. So guys, get your facts straight. Start thinking about broader horizons when talking about the age of the Earth, okay? Take into account other calculations. Now, what about carbon dating? Surely carbon dating proves the age of the Earth? Well, actually no. Carbon dating works because of cosmic radiation entering the atmosphere. Our magnetic field burns up a lot of that radiation, but some of it does make it into the atmosphere, and they combine with other elements to form carbon-14 atoms. Those carbon-14 atoms are consumed by living things on the planet. When they die, they're fossilized. We can calculate the amount of carbon-14 atoms that is in the fossil and thereby determine the age of that fossil. The problem is exactly what I just said. The magnetic field burns up a lot of the cosmic radiation. Now the Earth's magnetic field is getting weaker and weaker and weaker every year. That means that there's more C14 atoms being formed today than there was a couple of thousand years ago. That's why carbon dating only works back up to a couple of thousand years, maybe about 50,000 years max, okay? So what about the DNA we extract from fossils? Well, that would not work either, because DNA is very fragile and it breaks down over time. The decomposition process of DNA, when exposed to the elements such as heat, water, sunlight and oxygen, speeds up drastically. Now scientists have estimated that under the perfect, most ideal conditions, DNA can survive theoretically for a maximum of 1 million years. Okay, that's the perfect conditions. Now the oldest found samples of DNA come from Greenland underneath the ice. Now that is a perfect natural freezer for the DNA, and even those samples they estimate to be between 450,000 to 800,000 years old. Okay, so that already decreases drastically what we can do with the DNA. So extracting DNA from fossils is not possible, especially if the fossils are older than 1 million years. Okay, so what about the stars? Surely if a star is a couple of billion light years away, it takes light from that star a couple of billion years to reach the Earth. Shouldn't that prove that the Earth is at least a couple of billion years old? It's a bit more complicated than that. The way scientists measure the distance to the stars is they look at a star at a certain point in its orbit, any date, okay, and they measure the angle between the Sun, the Earth and that star. Then they have to wait 6 months and look at the same star and measure the same angle, okay? So now they have two angles and a distance between the two angles of about 300 million kilometers, okay? That's the distances between Earth at one point of the orbit and at the other point of the orbit. With two angles and one distance, you can calculate the size of the third angle and the distance to the third point in the triangle, okay, using simple trigonometry. That would leave you with a very long and skinny triangle. The third angle is extremely small. Even with today's technology, we can calculate the distance in this fashion up to about 400 light years, okay? 400 light years is not a lot. That means it takes light from that star to reach the Earth only 400 years. Okay, so that's a very small distance considered in space distances, okay? So further than that, the angle gets too small for any computer or any math genius to actually measure it, okay? Even with the best technology, let's say, okay, NASA has new technology, let's put it up 500 light years, okay? Even 1,000 light years, that is still much less than billions of light years. So that way is the only way we can almost certainly measure the distances to the stars. Further than that, this technique does not work. Further than that, scientists use a different technique. They use the brightness and the color of the stars, but then a lot of assumptions come into play, and assumptions do not make for very good facts. So yeah, basically that's it, okay? The distances to the stars doesn't work because no one is sure of the real distances further than 400 light years, okay? Okay guys, this video is finished. If any one of the things I talked about today is true, then the Earth is young, it's not old as scientists want us to believe, okay? People will tell me, well, scientists say it, so it must be true. Well, we saw in some previous videos that there are scientists saying the Earth is flat and it doesn't flatten it out, okay? Scientists said a lot of things in the past. What we know of the Earth today and what the scientists say, it's only theories, okay? It's not proven, it's not a fact. You have to believe in it for it to be true. Okay, so if any one of the things I talked about today is true, it's proof of a young Earth. And these are just a couple of ones, okay? The number of proofs against the old Earth is so unlimited, okay? You can take years to go through all of them and still see that the Earth is young, okay? There's the evidence of human history. If the Earth is older than a couple of 100,000 years, there should be a much greater population today on Earth or during the past. If we look at the rate of population growth over the past couple of 100 years, okay? Apart from that, there's the solar system, the ice formations on the different planets. There's the saltiness of the ocean on our planet, okay? There's the different fossils. They found dinosaur bones in Madagascar that aren't even fossilized yet, showing that it must be less than 1,000 years old. Speaking of dinosaurs, there's proof they found traces of dinosaur footprints next to human footprints. It would not be possible if the Earth is billions of years old and the humans came into existence only a couple of million years after the dinosaurs. That would not have happened. Speaking of fossils, you determine the age of rock layers by the type of fossils found in them, and you determine the type, the age of fossils by the type of rock layers they're found in. That is circular reasoning. It doesn't work. Apart from that, there's pictures and proven facts of trees that have grown through many different rock layers. They're fossilized through multiple rock layers. That would not be possible, or else the tree would have had to be billions of years old as well. It would not work, and they put that picture in a book called Geological Enigmas because they don't know how to prove it and how it came into existence. And that book is a huge book, okay? The enigmas are limitless. It's just not possible for the Earth to be billions of years old. It should be a couple of 100,000 max, okay? It just doesn't work, guys. Just take it as you wish. I know a lot of people will not agree with me on this video. Maybe some people will agree with me. Like I said, I'm not taking sides with any group of people. I'm just taking simple science, logic and math to disprove a lot of theories, okay? If you want to prove the Earth old billions of years, send me that proof. If I'm wrong, I'm glad and admit them. But if there's no conclusive proof, okay, there's no fact for billions of years, then don't tell me it's billions of years old just because a couple of people believe it. Remember, guys, the truth hurts, so do with this video whatever you wish.